Hello stats, welcome to your fall final exam review video. Today's video is brought to you by Starbucks. Mr. Yak will not say no to a Starbucks gift card. And the semester is Thursday, so hurry up. Here's the answer number one. I'm going to quickly just go over the answers. We've done a lot of these in class, so please check them. On this one, round to the nearest tenth of a percent, and then make the pie chart look as accurate as possible. Here's the 5-number summary. Again, we should have done this one in class, but here again is the answer. 87 is the true median. There's the 5 numbers. That's how you make the box plot. Min, quartile 1, median, quartile 3, the max. 1.5 times IQR, defined an outlier. There it is. There's no number below 64.5 or above 116.5, so there are no outliers. Again, pause this whenever you need to. Going to try to get this finished quickly. Use the calculator. If it doesn't say by hand, then just simply go calc stat edit list 1, type those numbers in, then again hit stat calc 1 var statistics, 1 variable statistics x bar. Use the sample standard deviation for that. Build an interval of 2 plus or minus twice the standard deviation. All right, so we get that. 32 is an outlier. Okay, we didn't do the stem plot in class. Here they are. Again, if you see 72, write 2 twice. You need to put them in order, least to greatest. And one should be easy money. Number 5, this one you do by hand. Here is the, I don't believe I wrote down the formula I'm going to give you, but here's how you find x bar. You just add them all up, divide by 6. To find the variance, you find each individual x, and you subtract x bar, and you square it. You get 28. You take 28 and divide it by n minus 1. N minus 1, not n. Then you take the square root of that. That's your standard deviation. All right, so, you do need to write that. Again, x is IQ score, so the probability that x is greater than or equal to 105. This is not a sample. Just looking for one individual. Find your z-score. Greater than means you subtract from 1. Find the complement. What's the probability somebody has an IQ of less than 90? All right, so find the z-score. Less than means you keep the area associated with that z-score. Number C there, what's the probability they have an IQ above 120? 1 1/4, you subtract it. There you go. All right, SAT math scores are normally distributed with the mean of that, standard deviation of that. What's the probability you're going to get between a 5 and a 600? On the SAT math, all right, there's a z-score for 500. There's a z-score for 600. Again, find the areas associated with both, and then subtract those 2 areas. And moving on to number 8. I think we did this page in class. The 3 strongest ones are the ones that have an absolute value closest to 1. And the 3 weakest are the ones that are closest to 0. All right. So you take the square root of r squared to get r, and the slope tells you the sign. All right, this one should not be too bad either. Check those answers. Model 1 has the stronger, it should say stronger, not larger, has the stronger r value because when you take the square root of both, that's going to have the biggest absolute value closest to -1 or +1. It's going to have the stronger r value. All right, there's the slope, there's the y-intercept, and that's what they both mean, okay? So predict, you just plug in 8 for x. Find the residual, y minus y hats. I will give you that formula. Find the residual, again, plug in 6, find out what they should have gotten, and then subtract that from what they did. According to this model, if they want to earn at least an 80, we have done it this way. Some students have guessed and checked. Again, they should miss no more than 6 days, because if they miss 7 or 10, go under an 80. Who would have the largest residual? Again, that's a number furthest away from 0. It doesn't exactly mean it's got the biggest positive. All right, so find the predicted scores for both. Find the residual for both. There it is, 10.22. Not because it's a bigger number than 7.69, but its distance from 0 is bigger than 7.69. All right, so we have not done these, folks. Here's what I did. I put, again, you can do whatever you want, but you have x, x, y, put them in whatever list. I think one year I taught us, I told all the students to put the y's in list 1. Okay, so stat edit, list 1, list 2, list 3, there. Then you're gonna hit stat, calc, and regression. In my models here, list 1 is gonna be Y each time. So anyway, here's the batting average model. Here's the on-base percentage model. And then if they had a batting average of that, what was their predicted run total? There it is. Using the on-base model, if they had an on-base percentage of that, what's their predicted run scored? There it is. All right. Next one, GPA and ACT. So notice I said GPA is the explanatory variable, so that's X, that's Y. GPA list 1, ACT list 2. So you know, stat, edit. Then do stat, calc, and regression. Again, you guys are going to have to know how to type these in. I would expect one of these on your exam. Okay, state the linear regression equation for GPA. I believe that's the GPA one. Wait, no, GPA and ACT score. I'm sorry, it's just one model. There it is. That is the model. And it's correlation coefficient, so it's very strong. Calculate the residual. All right. So there we go. If a student has a 3.37 and earned a 25 on the ACT, did they overperform or underperform? So they should have gotten that, and they would have underperformed by 1 1/4 basically. All right, the next one here, the taxi and takeoff time for the commercial jets. We've done this one so many times. So X bar, you need to divide that by 50. X bar is 9.9, so what's the probability X bar is less than 9.9? This is the first central limit theorem question because you have a sample size, so you need to use this formula. You'll be given that. Anyway, that's the z-score. Because it's less than, you keep that area associated with it. More than, you divide. So I should have put the probability that it's greater than 9.7. And do 1 minus because you want more than, so there it is. And it's between those two, so you've already got that. See, folks, on your last test, some of you lost a lot of time because you calculated these z-scores again. Folks, you literally have that info before, so don't do the work twice. So just subtract the areas associated with both. There's your answer. We're talking about male heights. Okay, notice how the sample size is less than 30. Normally that's a problem, but because it comes from a normal distribution, it is fine. So what's the probability that the mean is going to be greater than or equal to 70? There's a z-score associated with it. And then there's the answer. You got to subtract it from 1. And then what's the probability that they're going to have a mean height of at most? So less than or equal to 65.7. Very, very low. And then what's the probability that they're going to be between 68 and 70.5? So you don't have any of that info. You do have to calculate 2 z-scores. There's the first one. There's the second one. So it's almost 100 there. 100% chance almost. All right. This next one, again, central limit theorem. Because it's asking, first off, you're going to sample size, and then it's asking about mean. Okay? So what's the probability that the mean is going to be less than or equal to 4.7? There it is. So take your time checking this, pause it whenever you need to. What's the probability that the mean is going to be 5.05 or more? There it is. And then here we go. We have another central limit theorem question. You have a sample of 200 values with from a population with that mean and that standard deviation. What is the probability that the sample mean will be in that interval? Okay, so there's your first z-score and your second z-score. And simply subtract. What's the probability that sample mean will be greater than 550? Basically 0. Here we've seen this one before. It's a conditional probability question. Yes, I do need you to write that out. What's the probability of the sum? So x is 4 or 5, given that x is less than 8. Okay, so 4 or 5, there's 7 of them. Given that it's less than 8, you're only using this part. There it is. So you can write 0.333. 1/3 is also all right. 19, got some conditional probability. There it is. So the smoker is the denominator, no degree in, smoking's the numerator. I'm going to go through this kind of quickly, but again, notice the statement I wrote. You're going to have to write that too. Not smokers the denominator, not smoking in college degrees the numerator. Just what's the probability they have a college degree? So college degree over total. No degrees the denominator, not smoking no degrees the numerator. Given that they have a college degree, so degree is the denominator, college degree, and then smoking is the numerator. There you go. You spin a spinner labeled 1 through 4 repeatedly, so you observe the first one at which you stop. Let x be the total number of spins. Find the probability that it's less than or equal to 3. Probability of success is 0.25. So here, you want to, if you want to win on the first spin, you want to win. If you win on the second spin, you want to lose, then win. And if you want to win on the third spin, you want to lose, lose, win. Then add them all up. Okay, here's the earn question. None of them are orange. There you go. What's the probability of at least one green? So 1 minus the probability of no green. There you go. What's the probability that you will win the game in 4 or fewer attempts? So just like the spinner, you want to win, you want to lose, win, lose, lose, win, lose, 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 win. You should only say 0.32 once in each situation, and then add them together. Okay, here's the defective problem. Probability it's defective is probability it came from A times probability it's defective from A. Probability it came from B times the probability it's defective from B. Plus probability it came from C times the probability it's defective from C. Add those up and then do write those numbers down because you're going to use them. There it is. What is the probability that the unit is working properly? Well, it's just 1 minus the probability it's defective. Given that it is defective, so 0.355 is the denominator, what's the probability that it came from C? This number right here. That's the numerator. Given that a randomly selected unit is working properly, so that's the denominator, what's the probability it came from supplier A? Well, it's going to be 0.60, not times 0.03, but times 0.97. You want it to work. All right. And get close to the end here. Here's the independence. Or the independent, that's probability of A, that's the probability of B. And then you got to look at their intersection. A intersection B is 3 out of the 36 sums. A 12th does not equal that product. That's how you show me no. Notice how I showed all the situations of probability A and B. Okay, you have to show me those. That's probability of A, that's probability of B. And the intersection, I showed all 9 of them. And look at that, a quarter is 1/2 times 1/2. Baseball players should probably talk about this one. It's been a while. What's the probability he's going to get at 1 hit? If the probability of success is 0.364, then we need to do 1 minus the probability of no hits. So we have to do 1 minus the probability of failing 5 straight times. There it is. All right, here's the vote. That one shouldn't be that bad. 27, Washington, Stanford. There you go, their intersection. Then do 0.56 minus that, then do 0.63 minus that. Probability of neither is that. Then literally you can answer any of the questions from there. Okay? What's the probability only WashU admits you? What's the probability only Stanford admits you? Well, it should not be that bad. Here is the 3 circles. Again, so probability of A and B literally means that chance in this example. Okay, here's that Venn diagram. Only Dartmouth. There's probability you get into 2 of the 3. There's a probability you get into at least 1. All right. And almost done here. The math students, again, you're gonna put 103 in the middle there, and then just subtract 122, 103, 166 minus 103. 12 haven't taken either of the classes. There's 197 total, as it said. All right, there's that one. Answer to D. There you go. And the last page. Probability to make at least 1. That's just 1 minus the probability of missing all 3. What's the probability to make at least 2 of the 3? Make, miss. Make, miss, make. Miss, make. What's the probability to make all 3? It's simply success to the 3rd power. There's the sample size for flipping 3 coins, head, 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 all the way to tails, tails, tails. And then what's the probability of rolling a sum of at least 8? There's 36 sums. Those are all of them that are at least 8s. There we go. All right, folks, you do have I think the 3 other pages that I made as a new review that you guys also need to look at. We should have done those in class. And this is Yak Math Videos signing out.